Hello, my name's Roger and thanks for dropping by. I've got a gadget here that's meant to make a mild cleaning sterilising solution from nothing more than water and a teaspoonful of salt. And it does that by electrolysis, and we'll run through the procedure in a moment. I'm not here to say whether the product's any good or whether it's bad or anything. I'm completely indifferent about that. And that's not the purpose of this video. What I want you to do is keep an eye on the little indicator light at the bottom as it goes through its sequence, and after that's finished we'll come back and talk about it again. And please do stick with it because I do need some help. Right, so let's get cracking. We take off the top, fill it with its measured teaspoonful of salt. And this is a venting cap that goes on top. Let's give it a little shake to make sure the salt's around. Hopefully that's in frame. And we'll just plug in the power supply. Now the first thing I'm going to do is make sure I've got a 5-volt adapter. Yep. And plug it in. I know there's no little light or anything on the front of it, and I'm going to zoom in a little bit before I start it. Get ready, here we go. And you can see that there's no light at the bottom, and this thing is fizzing like crazy, which I suppose is meant to give you that feel-good factor. Oh look, it's doing something. The pressure build-up inside is vented through this cap, it just bubbles out the top. Not really much to say until it's finished, so we'll probably fast forward through this bit. How long does it take, that thing, darling? How long does it take to make that? How long does it take to make that stuff solution? 10 minutes? You know that? Okay, we've completed making the solution. Now green. I'm going to unplug it and open up the top. Don't sniff it, it does smell of chlorinated water, it smells a bit like a swimming baths now. And you don't want to go smelling things like that. And that is all ready for action. So what is the problem? Well, I have one here that's in bits because I took it to pieces. And one. I have another one. Both of these are broken in that they don't work, and it's not the fault of the manufacturer, it's the fault of the person who was using them. And the lady concerned didn't realise that she had the wrong power supply unit for it, and plugged it in one that was would run quite happily at 12 volts. The real problem is these things. There are so many out there that will fit anything and are poking out sort of stupid voltages. So I've got adapters that are poking out 20 volts, 12 volts, 10 volts, 15 volts, 5 volts. Yeah, I've got dozens of them, and I've got a big box, and every time I have to use a piece of equipment I have to find a power supply that works with it. So I'm quite happy checking every time I use, but somebody in a domestic environment may not be, and that's the reason these two things have been blown up. We're going to look at the circuit now. This is the circuit board out of the device. The larger components mounted on one side, and on the other side we have the surface mount devices, which are mostly resistors, a couple of capacitors, a MOSFET, and a small integrated circuit. Now we'll look at that in more detail and run through the diagram and how I think it should work next. Although it's only got 8 pins, it's an odd little chip. You can pack an awful lot of electronics into an 8-pin package. We'll start on pin 8 is pretty odd for this form in that it goes down to ground. Pin 1 goes to +5. We have pin 7's got a 10k pull-up resistor. Pin 4's got a 10k pull-down resistor. The LED is all one package, and the red LED glows dimmer than the green LED. But so we're going to assume that pin 2 and pin 3 are both outputs. Pin 6 is an output which drives the MOSFET on, and pin 5 is some form of control input which is regulating the system. The capacitor, microfarad there, 47 microfarad electrolytic, is there to sort of cut out any ripple on the 5-volt rail, and the small capacitor is to cut out the higher frequencies and sort of shorten down to ground. I believe that the other capacitor over here is performing a similar function, just cutting out noise on that control line. As an assumption on my part, I don't think it's part of a sort of timing circuit or anything, although I could be wrong. So what do I think happens? Well, here's the on switch, so the momentary on switch starts the process at pin 7. Pin 6 probably goes high and switches on the MOSFET. The electrolysis starts to take place. Current flows back through down to ground. These are very low ohmic value resistors here, so we've got a sort of a ratio of the on resistance of that with those, given sort of a potential divider, providing a signal to that pin 5. Pin 5 recognises that the MOSFET is on and switches on the red LED. Green one remains off. And about 10 minutes later the process stops and the green light comes on and the MOSFET switches off. Now at this point it would be reasonable to assume that the conductivity of the fluid changes and that the changes cause a potential difference at pin 5, and the process is now complete, and that's why pin 5 then goes to whatever condition it needs to be and switches the system off. Sounds a little bit too good to be true, and I'll talk about that later, why I think it's probably not doing that. It's difficult to say what this device is, and I've not been able to find anything to match it. I've looked high and low looking for a chip that would meet the criteria required here, and I've failed. I've been thinking that perhaps it's some form of power control switch, and what with the electrolysis process. It reminded me of sort of lead acid battery charging, and I did think to myself that perhaps it's some form of battery charger control chip, and I'll talk about that a little later on. I've not found anything to match this device. If anybody out there knows anything, please leave a comment. As it takes about 10 minutes for this to complete itself, I'm going to sort of remove the 10 ohm resistor, short the drain to ground, and just plug the power supply in for 10 minutes. That's okay for me, but it's not okay for other people. And you know, it's the only way we're going to get a little bit of life out of this thing until we replace this chip. Or two, find out how this circuit really operates, and then redesign the internals to mimic what's being achieved here. And I'll talk about that next. Once again, I'm stuck in a disused corner of the house to make a video, and these are the two broken units. We have a third which is in use, and if I took that apart to test it, the boss would probably castrate me. I added a potentiometer to the circuit board so that I could switch the MOSFET on and off. I then coupled it back up to the bottle and filled the bottle with water, added the salt, and then switched it on and ran it for a period of 10 minutes. I then borrowed the working one, emptied it and refilled it with the processed water from this one. Now my reasoning was that when I switched it back on, it would either come on with a green light or at worst come on with a red light, which would stay alight until the process had reached its completion after a minute or two perhaps. However, I was wrong. The red light did come on and it stayed on for 10 minutes. It does sort of indicate that this little board is running as a timer circuit of sorts. And why do I think it could be a battery charger control chip that's been adapted for use in one of these? What little I know about battery chargers is once the fully charged voltage is reached, they switch off. Now if you do that with a lead acid battery, what happens is it will fall back a few hundred of millivolts, and you will be slightly below the fully charged voltage. So it's not uncommon to carry on for a set period after that before switching the charger off, and the charger is switched off basically to prevent from overcharging the battery. It's a sort of a halfway compromise of making sure your battery is fully charged. I have reason to believe, by reading some specifications of battery charger control chips, that what happens is that once the fully charged voltage is detected, this initiates a small timer circuit, onboard timer circuit inside the chip, and then after that has timed out, the charger is switched off to prevent battery overcharging. And I think that's probably emulates what I think is going on in this on this board. If anybody knows what this chip is, please let us know in the comments. It would be, in my case, very useful. Now, if we have to repair one of these, by rubbing off the information off of the integrated circuit, it pushes up the amount of time that it takes to find a replacement and repair such items. Now, if you're doing this commercially, that obviously puts the price of it way up, and therefore makes this product sort of unrepairable. Now, I do this as a hobby. I don't do it for money. I do it because I enjoy doing it, full stop. And we do have a right to repair. There's no danger we're going to come to if we try to repair one of these. It works off of 5 volts, 1 amp. It's what I call a common mode of failure, in that I've got two here that are broken. They were broken in the same way, by plugging in the wrong charger, and that's the fault, that the charger socket will take a multitude of different voltages. Now, the design itself, the design of this circuit, doesn't protect against that, and that, in my opinion, is a flawed design. And this really condemns these to being nothing better than plastic electronic waste, which is rather sad in this day and age. My next step is to sort of duplicate this part of the circuit around the MOSFET and test all the voltages and currents as the process of electrolysis goes on, so that I can actually work out what it really is doing. Because in my opinion, all it's doing is detecting that there's a current passing through and switching the device into the timer state. Once we understand what's going on, I'll be able to then decide upon what sort of circuit I need to design to duplicate the process. But I'll only do that if we can't find out what the chip is. I think that brings me to the end. Catch you next time, guys.